September 26, year 2009, Tropical Storm Ondor ravaged Luzon. And submerged areas like Metro Manila and flood, wrecking thousands of lives and billions worth of properties. Every year, typhoons and tropical storms expose Filipinos and their properties to risk and damages. Thus, the Department of Science and Technology, with the goal to utilize science and technology to come up with high-impact disaster management and prevention solutions, was in full support of the Advanced Science and Technology Institute's development of a hybrid weather monitoring system and production of weather and rain automated stations. Launched in 2009 with the aim to deploy a network for automated weather stations, or AWS, and automated rain gauges in different strategic locations across the country. This initiative will complement Pag-asa's weather forecasting system. The locally developed weather monitoring stations were first built under the Hybrid project. Later on, the Hydromet project launched in December 2011. And the DOST project, launched in July 2014, emerged. Both projects deployed the hydrometeorological stations. The Disaster Management and Prevention Initiative was further bolstered with the launch of these two allied projects. ASTI collaborated with the DOST regional offices for the installation, maintenance, and field calibration. Pag-asa also took major parts in the project and handled the site identification and verification through conducting the hydrographic and hydrologic surveys. So what are the various stations and components?
ASTI engineers and researchers developed a locally designed data logger called the ARQ, or the Advanced Remote Data Acquisition Unit. It is the heart of each station. It is a low-power device that can store, acquire, record, and process data acquired from various sensors. The Automated Weather Station, or AWS, are monitoring stations equipped with various sensors for monitoring wind speed and direction, air temperature, air pressure, air humidity, rain amount, rain intensity, and duration. The Automated Rain Gauges, or ARGs, were developed to record rainfall data and send them periodically. These data are shared with partner institutions for further analysis. The Water Level Monitoring Station, or WLMS, is a monitoring equipment with ultrasonic sensors that periodically measures on-site water level.
The Tandem Station, or WLMS, with ARGs, monitors both the amount of rainfall and the rate of the water level. All tandem stations are equipped with ASTI-developed ARQ.
To provide the public a better experience on accessing the weather data received from the different stations deployed all over the country, the Advanced Science and Technology Institute designed and developed the Field Sensors website.
So how does it work? The stations gather on-site information from the environment. Collected data are sent via cellular network to a central database. The stations also send information to the database via satellite as backup. The data in the servers are reflected in the ASTI website and API services, allowing the data to be accessible to partner institutions. Milestones. During the implementation of the Hybrid project, it was able to deploy and install 81 AWS and 100 ARGs. Meanwhile, the Hydromet project, which started year 2011 and ended 2014, deployed and installed a total of 1,028 stations and designed a new data logger called the Advanced Remote Data Acquisition Unit, or ARQ. The DOST project, which started year 2014, has installed and deployed a total of 500 Hydromet devices and 500 early warning stations. Feedbacks from the communities have proven the devices to be effective in warning communities on the hazards caused by typhoons. ARG and WLMS are their basis for effective preemptive or force evacuation. Meanwhile, tracking of flood level has been easier through the use of WLMS. The device efficiently monitors water levels, especially during heavy rainfall. Meanwhile, the significance of hydrometeorological devices was emphasized by Region 10 Director Alfonso Alamban. Through the local disaster risk reduction and management offices, the LGUs are now capacitated and empowered in coming up with a science-based weather monitoring and flood forecasting using the EWS instruments. The data collected from the devices enhances the decision-making on warning alerts and evacuation plan. No casualty was recorded on Region 10 when the area was hit by Typhoon Pablo and Tropical Storm Senya. Significantly, the data was used as a basis for precautionary measure in Mimaropa when the region was hit by Super Typhoon Yolanda, resulting to 0 casualty. While the installed hydromet devices aided in monitoring water level in the area, preventing any casualty when Romblon was hit by Typhoon Nona. The project has made significant strides since it was launched in 2009, proving that when Filipino ingenuity and science, disasters can be managed and averted. Some significant gains have been achieved along the way. The Intellectual Property Office, or IPO, granted a utility model to ASTI, while ASTI gave a non-exclusive license to produce and distribute production of the ARQ to Alexan Commercial in 2015. The research paper on hydromet stations was even presented in the Global Humanitarian Conference in San Jose, California last October 21, 2017. The project also proved to be an excellent human resources development training ground as hundreds of staff from both ASTI and regional offices were trained to handle the deployment, installation, maintenance, and troubleshooting of the stations. The 3 projects, Hybrid, Hydromet, and DOST, were accomplished from the year 2009 to 2017, with each project accomplishing its goal and exceeding the target number of stations for installation.